Hello everybody. Today we are going to talk about Kruskals algorithm. Kruskal algorithm is one of the algorithms for calculating minimum spanning trees. So, what is the basic crux, basic idea? Let's just look at the salient features. Kruskal algorithm starts by looking at the entire graph and selects the edge that has the minimum value. It then selects the next smallest edge and keeps on doing that, which means that Kruskal algorithm selects the edges in ascending order from the smallest to the largest, keeping in mind what? Keeping in mind that they don't make a cycle. We don't have to make a cycle. Kruskal algorithm considers the entire graph as a forest and selects the edges and adds the edges in trees, and so it can be worked in a environment of disconnected graph. As we studied in our Prim's algorithm lecture, the Prim's algorithm does not work on disconnected graph. It can only work in a connected graph. But Kruskal's algorithm can work in a disconnected graph also. So let's take an example and solve it. This is an example. We use the same example for Prim's algorithm also. Let's start. So based upon the salient features of Kruskal's algorithm, we first select an edge with the minimum weight, which is HG. HG or GH, whichever you want to call it, because it's an undirected graph. The second one that we have is GF and CI. We can select either one first or second. That's up to us. Doesn't matter. Then we have the next value 4. Next smallest value is 4, which is on two edges, AB and CF. We can select them both first, whichever one we like. For example, we select AB first and then we select CF. After 4, the next value is 6, but we cannot select 6. Why? Because it makes a cycle. So IG edge cannot be selected. After that, we have two more edges of value 7. CD, we can select that, no problem. HI, we cannot select that because it makes a cycle. 8, AH and BC, we can select either one, but over here we have a situation. The situation is that if we select BC first, we will not be able to select AH, and if we select AH first, we will not be able to select BC. Why? Because when we select one, the other one tends to make a cycle, so we cannot select that. Moving on, DE is our next edge. After that, the next edge is 10, but we cannot select EF because it forms a cycle. Similarly, we cannot select BH because it forms a cycle, and we cannot select DF because it makes a cycle. So we have traversed our entire graph and we have formed a minimum spanning tree from Kruskal's algorithm. Fine. Does it follow the rule for minimum spanning tree? That is, the total number of edges should be one less than the total number of nodes. Yes, it follows because there are 9 nodes and 8 edges, right? And the total sum of the weights is 37. If you look at the video of Prim's algorithm, we use the same graph, and over there the edge BC was selected and AH was not selected, but still the total weight of the MST from the Prims also came as 37. We can redraw the Kruskals, we can redraw the spanning tree from Kruskal this way. Fine. Now, the big feature of Kruskal that Prims doesn't follow, what is that? It can solve disconnected graph. So let's take an example of a disconnected graph. Now we have a disconnected graph, that is two small subgraphs. Let's follow the Kruskal's algorithm. So the smallest edge is GF. We take that. and put it in the spanning tree. The next smallest is what? 4. We can there are two edges of weight 4, A, B and C, F. We can choose both in either order. Then the next one is 7, which are two edges C, D and H, I. We can choose either in whichever order we like. Next we have 8, that is AH. We have added in the spanning tree. Then DE, we added that in the spanning tree. After that, 3 edges are left. EF, we cannot select that, it makes a cycle. BH, we cannot select that, it makes a cycle. And DF, we cannot select that, it makes a cycle. So now, in this disconnected graph, there are two subgraphs. So there will be two spanning trees, one for each subgraph. So does it follow the rule of the minimum spanning tree? Yes, it does. How? Because one spanning tree on the left is A, B, H, I, and there are 4 nodes in it, 4 vertices in it, and it has 3 edges. Okay, what about the other one? The right side subgraph has C, D, E, F, G, 5 nodes or vertices, and has 4 edges. So again, both of them individually follow the minimum spanning tree rule, and we can say that the MSTs of the total weights, we can calculate them also, and you can redraw them in the following manner. So I hope you like the video. Kindly click subscribe and click on the thumbs up. Thank you very much.